elementary quantitative methods, that's the module QMI1500. Alright, so the first bit is just some basics. You'll see we'll look at numbers, working with numbers, so basic laws and operations, priorities, brackets, law of operations. Then we'll look at a variable. Okay, variables are placeholders, okay, x and y. So instead of putting in an unknown variable, we just call it something. We call it an x or a y or a z. Fractions, we'll look at that. Then we look at division, multiplication of fractions, addition and subtraction of fractions. Right, then decimals, we'll discuss what that is. Powers and roots, that's looking at exponents. Okay, so x squared, x cubed, those are powers. Roots would be the opposite. So two numbers that would multiply to give me the answer. So for example, root 25 would be 5 times 5. So 5 would be the root of 25. So it's the opposites. Then we've got ratios, proportions, and percentages. We've got signs, notation. So the first chapter is all basics regarding maths. Right, so after having covered chapter 1, I'd be able to judge on how good or bad your basics are in terms of like simple adding and subtracting, multiplying, ratios, proportion, percentages, etc. Okay, so that's what we'll look at in chapter 1. Right, then chapter 2 is stats, collection and presentation and description of data. Right, so this is looking like mean, mode, median, and those type of things. Okay, so we'll definitely do chapter 1 and 2 today. We'll probably even be able to do 3 depending. I think there's 7 chapters in total. Yeah, so I'm hoping to try finish at least 3, maybe even 4, depending on how well you understand the basics. Okay, alright, then we've got indexes and transformations. An index, you'll see, is just it's like a base. So like, for example, you've covered economics. Yeah, so you know what the consumer price index is.
Yes.
Okay, it's a measure of how cheap or expensive goods are currently based on previous years. Okay, so that's what we'll look at there in terms of price indexes, quantity indices, value indices, etc. They even talk about CPI here actually as well. Okay, then just some transformations here, which is looking at like conversions and calculations. Then you've got some notes here about functions. This will be graphs. All right, so that's kind of where we'll end off today to try finish the first 4. Then you've got some other concepts here which we'll probably cover later on. Okay, so let's see how we do. Let's obviously go to the first chapter. Okay, so chapter 1, numbers and working with numbers. This is all basic. So when we look at numbers, obviously basics are important because they're going to come up elsewhere. So this is numeracy skills. Okay, this is like your adding, subtracting, multiplying, and all of that. Yes, you are going to have a calculator with you in the exam, so you don't really need to worry too much about this. Okay, the basics are here just for doing calculations later when you have like an equation. Okay, so something equals something else. Then I need to calculate a missing figure. Then basics are important in terms of adding and subtracting, multiplying and dividing, and those type of things. Okay, so numbers, purely based on skills, working with numbers, having different things. So what do we have here? Well, right, first thing is priorities. Right, so you've probably heard of this. This is to summarize what's in the textbook. Okay, BODMAS. Okay, what does BODMAS stand for? B-O-D-M-A-S. Okay, the BODMAS is for the brackets.
Where do you get that?
No, I'm writing it down. This is my own summary for this. Okay, so BODMAS is brackets of division, multiplication, addition, and subtraction. Okay, that's BODMAS. Right, so what does BODMAS do? BODMAS gives you a rule to follow, or rules to follow, in terms of the order of operations. Okay, so when I say order of operations, I mean, well, if I have division and multiplication and addition and subtraction all together. For example, if I have 4 times 5 plus 4 divided by 2 equals question mark. Okay, if I have something like that, obviously the calculator is going to apply BODMAS. Right, so the calculator does that. Alright, so if you type that into your calculator, it'll give you the right answer. Why? Because it follows this. Are there any brackets here? No. Is there any of? No. Division? Yes. Okay, so division is there. So the calculator actually does that first. Okay, just to highlight it with the brackets. Okay, the calculator will do that calculation first. Then it'll look for multiplication. Is there multiplication? Yes. See, there's multiplication there. Okay, so then that will be calculated. And then obviously addition and then subtraction. So then the last thing is add the two together, right? Okay, so obviously this will be 20 plus 2, which is 22. Okay, but see, you don't have to know that if you know how to use the calculator. So type that into a calculator. 4 times 5 plus 4 divided by 2. No brackets, just 4 times 5.
Plus
4 divided by 2. 22, see? Okay, so it does that. Right, so you just need to apply this in case you have to do equations. Okay, left and right hand side equal and so on. Okay, so that's priorities. Okay, priorities talks about the order of operations. So for example here, okay, 2 times 3 is 6, 4 times 5 is 20. So 6 plus 20 gives you 26. Right, there's the answer. Right, so if you've gone through the textbook, you would have seen that.
Yes.
Okay, so I'm not going to go through every single page because that'll take me like 246 pages to get through. But yeah, I'm not going to do that. I'm just going to give you like the key things to take out of each chapter. So that's what you need to take out of this chapter. Make sure, or well, this section, make sure you get the order of operations right. And then if you need to practice, then you'd come and you'd actually look at some of these examples. For example, here, calculate each of the following expressions. Right, so if I look at this one, let's actually discuss it just to show you what this is. Okay, if I just copy that bit and let's discuss the answer to it. Okay, so number 1 is 4 times 3 divided by 2 plus 5. Right, so from a workings point of view, BODMAS would do this first. Okay, then it'll add 5. Well, 5 times 6. So 5 times 6 is 30. Okay, and then you would subtract, then brackets 20 divided by 4 times 2. Okay, so that's how it's going to group it. Why? Addition and subtraction come after multiplication and division.
yes.
Okay, so 4 times 3 is 12. 12 divided by 2 is 6. Plus 6 times 5, or 5 times 6 is 30. Minus 20 divided by 4 is 5. 5 times 2 is 10. Okay, 36 minus 10 is 26. Does that make sense?
Yes.
Okay, so that's what they should have done there. Yes. Right, so that's what they did. Okay, then they talk about brackets. We just spoke about brackets. Okay, if you have a square root sign, the square root sign acts like a bracket. Okay, so if I come back to the BODMAS here, this bracket slash inverted commas square roots. Right, so when you see something like this, square root, open bracket, all of that, then square root, all of that. So this square root means that calculate what's in here first. So what's 2 squared? 16. 3 squared? 9. 4 squared, which is 16 plus 9. 16 plus 9 is 25. Okay, so see, you're doing this bit first. Let me just get some comments.
Now this is quite easy when you use the calculator.
Of course.
Figure that out.
Yeah, because there's no need to do it manually because you have the calculator. That's why I'm not worried too much about this. I'm just showing you some basics. So see, that comes first. Okay, once you've done that, then you get that answer. Once you've done that, then you do this. Okay, so it gets treated like a bracket.
Okay.
Right, so yeah, if you have any problems with this, we can go through them later on. Okay, so I want to just give you key points from all the chapters in terms of theory. Then over the week, maybe go back and do some of the past papers and do questions that have like calculations and things like that. Okay, because then later on, next week I want to finish the theory, and then the week after I want to start with past papers. We might even be able to start next week, depending on how fast we go through the theory. Okay.
But I can't use this calculator. This calculator is
It doesn't matter which one you use.
So
You can use Sharp or you can use Casio
But I take both
for
of them
scientific.
into the
Yeah.
examination.
That's good, yeah. Then they just talk about these laws. Commutative, that's just looking at multiplication. So when you have something like this, 7 plus 3 times 3 plus 2, that's a bracket, so you add those two things first. Okay, if I'm adding and I'm adding, it doesn't matter which two I add. I can add those two together, then add those two together. Everything is being added, so it makes the difference.
Yes.
Alright, so see, things like that you don't actually need to know, because the calculator does it already.
Yeah.
Okay, so if you want to go through that and you want to understand why you're doing certain things, then go through the textbook in detail. Okay, obviously the priority is answering questions in the exam. Okay, and then like here they look at associative law. So associative is looking at, again, grouping things together. If you group those two numbers together, okay, and you're subtracting, right, is that going to make a difference to the answer?
Yes.
Well, yes. Why? Because this is 3 and that's 10 minus 3. This would be 5 minus 2, which is 3 and that's 7.
Yes.
Okay, so you can see they don't equal. Right, so associative law applies to certain operations. Okay, obviously subtraction and division here would make a difference. Okay, with addition and subtraction it doesn't. Right, so this is all background maths and stuff like that. You can go look at this. Okay, then we've got a note about a variable. Okay, what is a variable? It's a placeholder for a unknown. Placeholders for unknowns. Okay, what do I mean by an unknown? Well, let's say I've got
An X or a Y.
yeah, x plus, let's do this there, x plus 4 equals 9. What would x be?
5.
Exactly. Okay, so x is 5. Why is x 5? It makes that statement true. Okay, so it's just a placeholder. It's saying something plus 4 will give me 9. What is the something?
Yeah. And when it's a longer version. You just take it over and you get X alone.
Yeah, you can always manipulate the equation if you want to. They'll probably have that here. Yeah, don't worry about that. That you can look at in examples. Right, this is just telling you about rules. Let's look at some of these. Okay, so there. Determine the numerical value of the following. Right, what are they doing? They're telling you what x is. So they're giving you x and then you're asked to substitute. Right, so you can be asked to substitute a value in for the x, for the variable. Okay, because do you agree the variable is a placeholder for whatever you want to put it?
Yes.
Okay, it can be anything. If it's an equation, like that. So with equations, you have to have left-hand side equals right-hand side. Okay, for an equation.
Yes.
But because an equation gives you a statement, and that statement needs to be true. Yeah. So x plus 4 equals 9. Okay, that statement is true when x is 5. If x is any other number other than 5, you won't get a statement that holds true. Okay, so substituting values into variables apply when you only have expressions. Okay, so an expression would be something like x plus 3. Okay, that's an expression because there's no equation. Left-hand side doesn't equal anything. Okay, x plus 3 is just an expression for something. So I can make x1, I can make x2, I can make x3, I can make x3 whatever. Yes. So if I make x equal to 5, then what is the answer?
8.
Exactly. Ooh, typo. 8. Alright, and that's what you do, okay, with expressions. So that's an expression, that's an equation. Right, so if we look at one of these, for example, this one. If x equals 3, so then what will I have here? 2 brackets 3 squared. 3 squared is 9, 2 times 9 is 18. Right, so again, these are in the textbook. They're exercises. They give you solutions to these. What I would suggest you do is go through some of them, or go through all of them even. And if you can't do certain of them, then we can always discuss them. Yes. Right, but remember, the calculator actually does this. Yeah. Like you would literally type that into your calculator.
Yeah, that is still, yeah, section 1 is still quite easy.
Okay, good. So then we can go through it a bit quicker then. Alright, fractions. The only thing I want to say here about a fraction is you have a numerator divided by a denominator. Right, so the number at the top will be divided by the number at the bottom. And fractions can be represented as decimals. Okay, I'm bringing some other stuff in. And decimals can be represented as percentages. Alright, so what's wrong?
Decimals.
Decimals, yeah, thanks. Okay. Yeah, so decimals and percentages. Okay, so if I have, for example, 1 over 2. What is 1 over 2? A half.
Oh.
That's the fraction. Is 1 over 2 a decimal? Yes. So if you type 1 divided by 2, you get 0.5. Does that make sense?
Yes.
Okay, is 0.5 as a decimal and a fraction the same as a percentage? Yes. How would you get a percentage? Times it by 100. So this would be 50%. Alright, so that's the difference between fractions, decimals, and percentages. They all link. Right, you can write them in any method format that you want to. Okay, so all of those are equivalent. Right, a half is the same as 0.5 is the same as 50%. Okay, then they talk about that. They just talk about multiplying fractions. So if I have, okay, let's use this example. Let's use one of these examples actually. Where's the activity? No. That's adding and subtracting. Okay, let's see. Here's the decimal stuff. Where else? Okay, there's some decimal stuff. Okay, then power and roots. Okay, but yeah, that's later on. So I think let's just write one down. 2 divided by there plus 1 divided by 4. Okay, if I have fractions and they have different denominators, what must you do?
You must get the same denominator. So
exactly, get the common denominator. So convert the half to quarters and then leave that as a quarter. So 2 quarters plus a quarter gives you 3 quarters. Alright, so common denominator.
Yes.
Okay, that's what you need when you add fractions. What happens if I multiply? Well, then it's simple. Numerator times numerator, denominator times denominator. Yep. Right, so a half times a quarter. 1 times 1 is 1. 2 times 4 is 8. And that's it. Okay, so if you're multiplying numerator with numerator, denominator with denominator with denominator. What happens if you divide though? So a half divided by a quarter.
It's numerator divided by denominator and...
Yeah, you have to swap it around.
Yes.
Okay, so with fractions, you can take that and you can swap this around.
And make it 4 over 1.
Yes, okay, to make it multiplication.
Yes.
Okay, because it's the opposite. Division is the opposite of multiplication. So you can convert division back to multiplication. You just got to swap it around. Okay, so then you have that. And then 1 times 4 is 4. 2 times 1 is 2. 4 divided by 2 is 2. Okay, but again, the calculator can do that for you. Alright, powers and roots, that's obviously looking at this. Okay, a stream of numbers. Alright, that are the same. So for example, 10 times 10 is 10 squared. Okay, so we don't have to write 100 and we don't have to write 10 times 10. We can just write down 10 squared. So the exponent tells you how many of these things you've got. Okay, so if I have x, okay, I'm not going to be able to do an exponent. I'm going to do this. Okay, 4. Right, what does x to the power 4 represent? It means this. X times x. Oh, okay, this is not going to work so well because I've got x's. Let's make this a y or something else. Let's make it 40 or something simpler. 5. Okay, that will be 5 times 5 times 5 times 5. 4 times. Okay, if it's 5 to the power 4. Alright, so that's what they're describing here. Okay, so that's fine. That should be fine. Maybe just a note. If I multiply exponents, then you add the indices or exponents. Okay, what do I mean by that? Well, here, if I have x to the power 3 and I'm multiplying that by x to the power 6, what would the answer be? X to the power
3 x and x to the power 6.
Yeah, so 3, so in other words, I'm writing this down. X to the 3 times x to the 6. What's the answer?
X to the 3 and x to the 6.
No, x to the 9. Okay, you add those two.
Oh, yeah, sorry.
Okay, it's the same base. Okay, like that.
Yeah.
It's actually the example there. So they have the same example. Okay. Alright, so when you have that, same thing applies. X's with x's. How many x's do you have? 5. See that?
Yes.
Y's with y's. How many y's do you have?
8.
8.
Okay.
Okay, so just keep it together only if you're multiplying. Multiplication is when you add the exponents.
Yes.
Okay, only when you add the exponents.
Yes, and division is when you subtract.
Subtract, exactly, yeah. So we can write a note there. Okay, so that would be x to the 9. Okay, this is when multiplying the exponents. Exponents. That's spelled right, yeah. Okay, so then if you divide, then you subtract the exponents. Okay. Alright, this you can obviously try practice on your own, the examples, fractions, exercises, anything else here. Okay, the root we spoke about, that's the root sign. Okay, so when I have root 25, this means what two numbers will multiply to give me 25? The same number. So that'll be 5. Okay, because 5 times 5 is? 25, exactly. Okay. Yeah, that's all fine, that you can practice. Okay, ratios, proportions, and percentages. Okay, what is a ratio? It's a relationship between numbers. Relationship between numbers. Okay, so if I have, for example, baking or cooking or something that requires specific quantities of something. Okay, so baking is probably the best example. Right, what does baking do? It uses a ratio of maybe flour to water. Okay, to other things as well. Okay, so that's a ratio. It's just a relationship. So I'm using like parts. So 2 to 3. 2 to 3. Okay, so that means 2 parts to 3 parts. Okay, so if I've got 2 cups of flour, I will use 3 parts of water, or whatever the case is. Okay, it doesn't really matter. That might not be realistic. It's like really runny. Okay, but yeah, you get the picture, I guess. Okay. Alright, so yeah, that's okay. Yeah, we'll look at how to actually use this in a question when we look at past papers. So then we can practice doing all of this. Yeah, percentages we spoke about, so that's fine. Okay, then there's some more activities that you can maybe do as to check. So the thing is, even though we're going through it now, obviously it's more like a crash course than like a week by week going through everything in detail. Yes. So because we're limited with time, what I would suggest is you go through some of those activities, and then if you struggle, then let's discuss it next week. Okay, and then let's look at other things after that. Okay, so just remember to practice as much as possible, but also keep it in line with the past papers. Okay, because like, for example, this, do I need to do it mathematically? Probably not. I might have to write down an equation, and then once I've got it, I can just use the calculator.
Yeah, most of the stuff you can do with a calculator.
Yeah. Okay, with signs, do you know what these things are? Yes. Equal to, less than, hey?
Yes.
If you have less than in this, that means less than and equal.
Yes.
Okay, when you have, oh, well, they gave it to you. Then greater than, and then greater than or equal. Alright, so that's all fine. Okay, that's fine. Those are just timelines. We can look at examples when we get there.
Chapter 1 is quite okay.
Okay, yeah, this is, I know you asked about this. Okay, so summation is writing down a formula for a series of calculations. Calculations. Okay, so example. Alright, so let's say if I'm adding a series of numbers together, like let's use this. Okay, do you agree? This is basically telling me to add up what? So I has the value of I there. So I has the value of 1 up until 10. So what this is actually saying is it's saying add up all the numbers from 1 to 10. That's what it's saying.
Yeah.
Okay, all of it, like literally this plus this plus this plus this plus this plus this plus all of it up until 10. Okay, so that'll be that's 10, 20, 30, 40, 55. Okay, so the answer would be 55. Okay, if you're just adding up all the numbers from 1 to 10. Right, can you do this on the calculator? Yes, you would just type in 1 plus 1, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10.
Or you just type in the sign.
Well, do you have the sign on your calculator?
Yes, on this one.
No, you can't use that sign because then you're using a stats mode. No. Okay, you'd have to do it manually. Okay, so do it manually quickly. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Okay, now do you agree? That's only for 10 numbers. What happens if you had 100 numbers?
No, I was just thinking the same thing.
You wouldn't want to do that, right?
Yeah.
So now let's say if I had this 1 to 100. Okay, so that means I need to sum up numbers 1 all the way through to 100. Okay, so let's see if your calculator does have a... Yeah, I see it doesn't. So then what you would have to do is you have to use a stats function on that other calculator. Yeah, this one does stats better. So this mode, stats 2. See there, stats 2. And then you could use these different things.
Because I just said shift and then that one.
No, you can't. You can't use this. You need to use the summation button. You can't. You can only do it with this. So you would use 1 here. So then I put the numbers 1, 2, 3, 4, 5, 6, and then like okay 5. Oh, let's do 7, 8, 9, 10. Okay, that's my data. Okay, so if I wanted to go out, so AC shift. Where's my stats button? Where's STA? Oh, here's it there. Shift stats. Then what I want a variable 5. Okay, no, that's the escape. Let's do that again. Shift. I want the sum 4. Okay, there. I want EX squared or EX. I want EX. So I want 2. 55.
Okay, but what if you have 1 to 100?
Well, then you'd have to have 100 in the table. Yeah, so that's why it's slightly different. Yeah, there are formulas for it, but you're not going to get 1 to 100. Okay, so you'll see the type of questions you'll get. 1 to 100 is pretty pointless to do because that will require a equation. So with summation, you do have certain equations. So like sequences and series. I don't know how much of this you do. So you're asking about 1 to 100. Okay, there is a mathematical formula for adding the consecutive 100 numbers. Okay, so there's a formula for that. Okay, we're not going to look at that unless we have to look at it. Okay, counting rules, that's fine, that's just counting. Permutations, okay, this is quite important. When you have this factorial, okay, so this exclamation mark means factorial. Okay, so when I have 5 factorial, that means 5 times 4 times 3 times 2 times 1. That's factorial. That you can do on the calculator. Okay, so 5 factorial, where's the exclamation sign? Yes, good. Okay, so 5 shift that button equals that answer. Okay, so permutations are only used when doing statistics. Okay, so just a note here. Permutations are for stats. Okay, factorials, i.e. that. Okay. Alright, so that, like for example, 5 factorial can be written in different methods. So the thing is, this exclamation just means all the other numbers multiplied.
Yes.
Okay, that's all. This is looking at statistics in terms of permutations. So meaning when I choose things. So with permutations, it's looking at place. So when I see the word permutation, remember the word place. Place is important. Place / position is important. Okay, example, horse racing. Okay, if you're looking at a horse race, there's always going to be position 1, position 2, position 3, position 4, position 5. Okay, or any race, doesn't have to be horses, but just as an example, place is important because if someone takes first place, is first place still available? No. Then you've got second place, then third place, and so on. Yes. So with this, you're looking at the different possibilities. Okay, so here, they used here, how many arrangements are possible for the first 3 places in a race with 8 horses? See? Okay, so what am I looking at? Well, see, I did this on the calculator. So where's your permutation button? There's it there, NPR.
Yes.
Okay, so N is the number of horses. So 8, shift, well 8, then shift P. Okay, I've got 3 places on offer. Okay, there's 336 different possibilities.
That's so awesome working it out with the calculator.
Okay.
Okay.
Alright, so use the calculator, use NP. Is it R? Yes, on your calculator.
Awesome.
Okay, so you don't have to do it that way, that's manual. You just type it in here. It's the same thing with the combination there. Combination is place is not important, so just write that down. Combination, place / position is not important. Okay, and then you use the button NCR. Here it was NPR. Okay, on your calculator. Let's look at an example. Where's the question? Here. In how many ways can a police captain choose any 3 of his 7 detectives for a special assignment? Okay, so how many detectives does he have? 7. Okay, so out of 7 detectives, he's going to choose 3. He can choose 35 different combinations. There. C R. Okay, which was 3. Okay.
Okay.
Alright, then they talk about the differences here that you can look at. I spoke about it. Place is not important or place is important. Yeah, that's fine. That's fine. Okay, exercises. That's just some fill in the missing blanks. Okay, units of measure. That you should be fine. Kilometers, meters, and all of that. What I am going to give you those King Henry. King Henry died a miserable death called measles. You've probably heard of that before. Never. Okay, that's interesting. Okay, so kilometers. Okay, then you've got H and D, which aren't so important. Then you've got meters. And then you've got D and C. And then you've got millimeters. Okay, so that's the measurement. Alright, this could also be kilograms, milligrams. Okay, so this could be a kilogram. Then that'll be a gram. And then that'll be milligrams. Okay, so let's just look at conversions. Okay, so if I want to convert 1 kilometer, let's use this one. If I want to use 1 kilometer, how many meters will I have in 1 kilometer?
1,000.
1,000, obviously. So King Henry died miserable death called measles. So King, so from K to M goes how many times? 1, 2, 3. So you have to times it by 1,000. Okay, so if I want kilograms to grams, I do the same thing. Okay, if I want to go from meters to kilometers, then I divide.
That's so amazing.
Okay, so if I had like 6,000 meters, how many kilometers? Okay, well, I want meters to kilometers. So 1, 2, 3. So divide. If I go to the left, I make it smaller. Divide by 1,000 is 6 km. Okay, right, just like simple examples, and you can do the same thing with grams. Alright, so that's what they've described here. Okay, they've just given you this. Okay, it's actually here. Okay, but they take it further, nanos and pictos and all of that. Alright, so the King Henry stuff. Okay, kilogram. Okay, see, they've put it in a slightly different order, but it's fine. Okay, but yeah, what you need is there. Okay. Length as well, just doing conversions. There's the example we spoke about. Okay, then meters to centimeters is 100. Okay, let's check. Meters to C. C is the centimeter. Okay, so meters to centimeters, how many? 1, 2. So 20 meters, question mark, centimeters. Okay, from meters to centimeters goes 1, 2. So 20 times 100 is 2,000 centimeters. Okay.
Awesome.
Alright, so you can convert that in your own time and check the answers in the textbook. What else is there? Okay, area. Area, obviously, you've got a shape. Okay, so the shapes that you'll probably get, a rectangle. Okay, so area for anything is the area or surface that it takes up. Okay, so this square is taking up how much space? But two-dimensional space, not three-dimensional. 2D. Okay, not 3D. Okay, there's no depth. Okay, there's no well, I'll discuss volume just now. Do they talk about volume here?
Yes.
Okay, so let's finish with area. Okay, so area for rectangular object is length times breadth. That's what it is. I think I spelled that wrong. Okay, length times breadth. Okay, so that's a rectangle. It's the same for a square. Okay, so if I had a square, it's still length times breadth. Still applies. Okay, but then length times breadth, length and breadth is the same basically, so it's the same thing. Okay, something else that you can also get is a triangle. Okay, with a triangle, area is half base times height. Okay, the base is that. Okay, that's the base. Oh, wrong button. It's gonna open up something now. I have to wait for it, sorry. Okay.
I'm really bad with this. Like, really?
What do you mean? Base? Area?
No, with all these, like, area and...
Okay, well you just need to study it. Okay, that's why I'm giving this to you now. Okay, because if you want to work out the area of a triangle, what do? You take half times the base times the height. Okay, so this is the height. Okay, height is perpendicular, so it's actually that. Perpendicular means 90 degrees. Did you do maths at school, maths literacy? What did you do?
We did, but I was never good with this. So algebra I was fine with that,
Okay.
and yeah. But the other thing is I was in Afrikaans school, so
Doesn't
the things
matter.
that you're telling me, like,
Oh,
yeah,
you just
I've
would have
never
called
heard-
it something different, that's all.
Yeah, well, no, we never.
Yeah.
I don't think we had that good teachers.
Oh. Okay, so we can actually go through those type of examples when we get there. Okay, if we do any of those triangle shape type questions, look at area. Okay, so that's area. We've looked at that. We've looked at that. Okay, volume. Right. So see, volume brings in the third dimension. Okay, so let's take this. Let's take that one actually. Okay, so volume is the three-dimensional space taken up by the object. Okay, so that's the three-dimensional space. So, for example, if I had that, okay, then I've obviously got a shape.
I think it's a box.
Yeah, exactly. Okay, and then what's important here, it's still this, so the area is still the same. Okay, so if I had to times length times breadth gives me this. Oops, wrong one. Okay, so this is area. Do you agree?
Yeah.
Okay, if I want the area of that rectangle, I'm going to times the length by the breadth. If I want volume, then what does volume do? It looks at the depth, okay, which is the length times breadth times height. Okay, it's that like three-dimensional space.
Yeah.
Okay, so then times this by, so volume is length times breadth times height. Okay, it's three things. Okay, that's volume. Right, length times breadth times height. So if you had this, a triangle, it's going to be a pyramid, not a triangle. Okay, it's going to be difficult to draw this. I'm not going to draw it. Okay, I'm just going to write it down. Volume of a triangle, three-dimensional triangle, is half base times height. Half base times height. Okay. Times, well, again, it depends on the shape. So can you picture picture a triangle? Okay, like, do you know a Toblerone?
Yes.
You know that box?
Yes.
It's
triangle.
It's triangle but long.
Yeah.
Okay, so if you had to visualize that box, it's just one triangle but many triangles.
Yes.
Do you agree?
Yes.
So just take the triangle times the length of the box, basically.
Yes.
Okay, because that gives you the volume, but that gives you the volume of the. Let's try again, like that. Okay, and then you've got like that there. Okay, but see, it's difficult to draw this.
No, but
Yeah.
I understand. Yeah.
Oh, actually, this will work. Like that. Okay, and then obviously you've got these lines here that go there.
Yeah.
Like that. Okay, so now the thing is, you've got this one triangle, but you've got so many of them because that's why it's got the length.
Yes.
Okay, that's why you just take the length times breadth. Okay. Okay, and then you times the inverted commas the depth. If that makes sense.
Yes.
Okay, because it's just the triangle, but many of them.
Yes.
Yeah.
Basically the inside.
Exactly.
Yeah.
The volume. Exactly. Okay. Alright, so yeah, this is fine. This is fine. You can go back and practice this. Let's see if there's anything else important that we need to summarize. No. Okay, perfect.